So good morning, everyone.
Good morning, sir.
Stanley Ndubisi, the Executive Director of Bon Maximus Companies Limited.
Good morning.
Today's training is on e-QS3 software. Bon Maximus Company is the developer of e-QS3 software, which is an upgrade of e-QS2. So the purpose of this training is to teach us how to use the software to aid our quantity surveying operations, one of which are the aspect of preparing bill of quantities, material estimating, and also getting updated prices of building materials from the comfort of our offices. So our training focus is going to be on areas of how to use the software to upload drawing, which is creation of projects. Then how to use the software for on-screen measurement. So those of us that have used Plan Swift, that aspect will not be difficult for us to understand. And next, we look at how to use the software for BOQ preparation, how you can use it to automate your BOQ preparation process. With the software, there's no need for manual calculations. We'll also look at how you can use the software to generate material schedule from the BOQ being prepared. Then lastly, we look at how to use it for market survey online. So I'm going to share my screen. Okay, can you see my screen?
Yes.
Okay, so I believe those of us that have the software installed, we have a similar interface. So we start with going through the tools on the software interface. So when you open it the first time, you have the home page, which shows you all the other tools. Then next we have quick measure. Quick measure is being used if you are on the prepare BOQ page where you are typing some values and you want to do a quick check of a particular measurement. You can use quick measure to measure the length or area of any aspect of the drawing. Then we have next, we have prepare BOQ, which allows us to prepare BOQ. We have different items there. We have work items, which is further categorizing to substructure and superstructure. So these are more of like inputs and a result form. It has forms for different items of work. So the building, for example, in substructure is categorized into different segments. We have the site and trench details, we have the column base, we have the ground beam, we have the columns, and so on and so forth. Same applies to the superstructure. So when we are working on substructure and superstructure, we get more information on these items. Then next we have the prices where you can get prices of different building materials. Then we have settings and help. Then if you go to the home page, you have access to different measurement tools. We have the new tool which allows you to start a new project. We have the open tools. If I click open, you can see it gives me access to the different projects I've worked on before. And if I want to continue with any of them, I can double click or just click and select open. If I click this and click open, it will open the project. Then when you have uploaded a project, you can rotate the page. Then we have scale tool, which is used for scaling. It is important to scale a page before you can carry out any measurement on that page. We have dimension tool, we have count tool, we have length for measurement of length. Count is for counting of items. We have slope length for measurement of slope length to get a slope length from the unplanned length. We have area 2 for measurement of area. We have volume 2 for measurement of volume. Then we have pan, which allows you to move the drawing around, then zoom, which allows you to zoom in, although you can use that with your mouse. So it's advised to use mouse when you are working with the software. If you don't have mouse, please, you need to get mouse because we are working with drawing. So to move around the drawing, to navigate around the drawing, you need mouse. Without mouse, I mean external mouse. Without external mouse, you cannot use the drawing, the measurement aspect effectively. So we are going to start with how to create a project. So the creation of project is in steps. So the first step, we can say step one, is to click new. So when you click this new tool, this form will come up. So on this form, you type okay, before we do that, let's decide on which project we want to work on. So I sent a drawing to our WhatsApp. So that was the drawing we are going to use. So you can create a folder. You can see I have a folder on my desktop. So you can create a folder on your desktop and you call it I call this folder project drawings. So in this project drawings, I now have another folder called 3-bedroom duplex. So that is where I put the file that I sent to you. So you can do the same. You can create a folder on your desktop and create another. That folder is a main folder where all your drawings will be stored in. So any new drawing I have, I just paste it here. But I need to create another folder to uh, put the drawing for easier uh, categorization. So when you open this is the file I sent to you. So you can see that I had to put it inside a folder. So that's the first thing. The first thing is to decide on the drawing, on the project you want to work on. So this is the project I want to work on. So next is I'm going to click new. So when I click new, so we can say step one is to decide on the drawing you want to work on. Then step two is click new. So when you click new, you have project number. So let's say my project number is 001. Then the title of the project is 3-bedroom duplex. The location, which is the client address, you can say is in say, yeah. Then open in this window. So this window is the default. So you click save and continue. So when you click save and continue, it brings out all the folders on your desktop. So I'll scroll down to the folder where I kept those projects, which is project drawing. You can see there's an arrow beside it. So I'll click the arrow. So please be careful. Don't click this box beside the arrow. If not, it will upload everything in that folder, and you may have other subfolders in the main folder, except if you just pasted the project you want to work on on the folder on its own in your desktop. But if you put it on a subfolder, then you use this to expand. So when you click to expand, then you click the folder you want to work on, which is 3-bedroom duplex. So you can expand further to confirm. So I have expand and I can confirm this is what I want to work on. So you can either check this, it will check or it will copy all the files in this folder. But if you are interested in only some particular files in the folder, then you don't need to check the entire folder. You can just expand again and just check only the interested files you want to work on. But me, this file has a lot of pages in it, so I'm just going to check this to upload the entire folder. That's the 3-bedroom duplex folder. So once I've done this, I'll click confirm. So when I click confirm, it will start uploading the pages. So although it's just a one file document, but it has 7 pages in it. So you see it's copying the pages. So after a while, depending on the number on the size of the file. So if the file is very large and has a lot of pages in it, it might take more time. But you see, this one is just 7 pages. So in some seconds, we have it. We have the project created. So we said this is a practical class. So what I just did now, I want you to repeat it. So the model of our training is going to be step by step. So you watch me to perform a task, then I'll give you like 5 minutes to repeat it so that we'll be going along with each other. So those of us that have the software, please, let's try this. Mrs. Mobolaji, are you with us?
Yes, I'm with you.
Okay, ma'am. So you
But I
can try.
quickly stood up. I went to do something. So please, can you quickly repeat how you uploaded the? I just met you when you were about rounding up so that I can follow the class.
Okay, so let me go through it again.
Thank you so much.
Okay, ma'am.
Thank you.
So to create a project, the first thing is you decide on the project you want to work on. That's the first step. And we've already decided that we want to work on 3-bedroom duplex. And the drawing, we have that drawing stored in a folder on our desktop. In that main folder, we created another folder, a subfolder inside the main folder, and we call that folder 3-bedroom, 3-bed duplex. Then that file which I sent to your WhatsApp, I just pasted it inside this. So here we have decided that this is the file we want to work on. Then once that is established, then on the software you can see new at the top left corner. The new tool is used to create a new project. So you click new. When you click new, this form comes up. So on this form, you provide the project number. So project number, I can say this is 0011. Then project title, say 3-bedroom duplex. Then the address, I say Jabi. Then once you fill this form, the next is you click save and continue. So when you click save and continue, you can see we have different folders in our desktop. So it gives you access to the folders in your desktop. Then you scroll to that's why we said you should put the file in your desktop, or you create a folder in your desktop and put the file in that folder so that it will be easy for you to locate the file. So you navigate to the folder that you created earlier on, and you pasted that file inside the folder. So this is the folder I created, project drawings. Then I click this arrow to expand the folder. So I pasted the new projects inside this project drawing folder, which is our 3-bedroom duplex folder. So we have a folder in a main folder. So you can say this is a subfolder in the main folder. So this folder, if I want to upload all the files in the folder, I will just check this box beside it. But if I want to upload only some of the file, then I'll click this arrow to expand further. Then I'll check the files that I want to upload. But since I want to upload everything, I'm just going to check this. Then once that is done, I'll click confirm. So we can say step 3 is to select the folder, then you click confirm. Then when you click confirm, it starts uploading the pages in the file you have uploaded. So after a while, you can see it's converting it 4 of 7 until it gets to 7 of 7. Then it takes you back to the drawing. So we have the file uploaded and the project created. So if I click open, you can see I have the previous ones I have worked on before is on this list. See, the one I created before is at the top here. Then this one I just created now is here. So when I click this arrow to expand, I can see all the pages that I have uploaded. Okay, ma. So did you understand it better now?
Yes. So let me try it. I want to try.
Okay, ma.
Thank you.
QS Louis, have you created the project successfully?
I'm just watching. I'm just listening and watching. So let's we can go
Okay.
ahead.
Okay, maybe you can practice after.
Yes, yes.
Sorry, please, I want to ask you a question. I
Okay,
believe
ma.
that it's recorded, this
Yes, ma,
session.
it's recorded.
All right, okay.
Okay, so let me rename the pages for better navigation. So this is our foundation layout. So to rename, I'm just going to double click on this and change this to foundation layout. Then when I'm done, I'll click enter key on my keyboard. Then that name will be stored as the new name. So this is the column basis and column section. I just double click, then highlight this and type the new name, column basis and column sections. And I'll click enter. So this is slab and beam. So this is beam sections. Beam stills. This is slab reinforcements. Okay, so the next is we'll look at how to use the tools So I made mention of rotate. So assuming the drawing is not in the position that you want it, you can use rotate to turn the page around. So when you click rotate, it will turn the page. See, it has turned the page. So in some cases, you might have the drawing inverted. So you can use this rotate tool to turn the page around. But if you have started some measurements, you cannot use the rotate again. You can only rotate the page before you start your measurements on that page. So the next we look at is scaling. So before you work on any drawing, you're supposed to scale. So to scale, you look for any dimension. I can use 1.2, I can use 4.09, I can use 3.7. So you can use any dimension that you like. Then after you scale, but the dimension you are using, you must clearly see the start point and end point of that dimension, of that value. And then the value should be clear. So I'm going to use 3.7 because I can see the start point, I can see the end point, and the value is clear. So to scale, I'm going to click scale. So when I click scale, this modal comes up. So then I type the value, which is 3.7. So when I type 3.7, I prefer to work in meters. So your scaling, even though the value is in millimeter, as you can see, the value is in millimeter, but you convert it to meters. So 3,700 millimeter to meters is 3.7. Then you click OK. So when you click OK, the cursor, you can see the cursor has changed. It is now active. So you position the center, you can see this, the center of this my point, the cursor, the center of it, where the vertical and the horizontal line intersect. That's the center. You position it at the start point of your measurement or the start point of the dimension. So you zoom in appropriately to see it. So when you position it, you left click once. When you left click once, you take it to the next. You zoom in again, you position it, and you left click again. So we have the scaling done. So that's how to scale. So when you finish scaling, you click dimension to check whether your scaling was done properly. So I'm going to use this 1.2 meters to check. So I'm going to click on the first point and then the second point. So you see, I got the same thing as what they have on the drawing. If you do your scale and you use dimension to check and you are getting something that is less than or exceeding the value that is in the drawing by a value that is plus or minus 0.1, then you know your scaling should be redone. So if you want to redo the scaling, you can right click and say stop. You click on this line. When you click on the line, okay, just to redo the scaling, you click scale again and repeat the process. So if I click scale again now, say already scaled, update, I'll say yes. So when I say update, then I can choose another value and perform the scaling. So let's say I want to use this same 1.2 for scaling. I can say 1.2. So you see, when I click 1.2, the first one I did went off. So let me use this one that is vertical to scale. So I can use this to scale as well. So when I scale, I use dimension let me use this one to check. So you see, I got 1.32. So you may not get exactly the same, but if you check 1.32 and 1.325, the difference is now up to 0.1, about 0.005. So this is still correct. So if you do your scaling and the difference when you check dimension, the difference of what's on the drawing and what your computer is giving you is the difference is not up to 0.1, then you know that your scaling is correct. So if your scaling is correct, your other measurements are supposed to be correct. But if your scaling is wrong, all your measurements will be wrong. So let me give you an example. Let's use this page as an example. Let's say this, if I use let me use this. This is 4.09. So let me use this 4.09 to scale this page. 4.09. So this 4.09 is supposed to start from year to year. So if I click here now as the first point, and I deliberately did not take it to the end point, I just, let's say by mistake, I click this point. Although it will still show me 4.09 because that is what I type. You are giving the computer a command that you are telling it, because originally the computer does not know what is the scale of this page. So you are telling the computer that from year to year is 4.09, and it will not argue with you. It will take it like that. So, but you as a human being, you are the one that knows the correct start point and end point of this value. So whichever position you give it, it will take it. So if your scaling is wrong, if you use click dimension now to confirm, let's say I want to check this from year to year, you see I'll get a value that is different from what we have here. So you see I'm getting 2.0 meter, which is far above what we have here. That's because my scaling was not correct. So if I should redo this scale now, update, this is 4.09. If I correct the scale from year to year, so you see scaling has been corrected. Then let me delete this ones. So let me redo this dimension. So I got 1.7. 1.7 is close to 1.695. So because the difference between this and this is less than 0.1, that's 0.005. So if you approximate this, is 1.7. So that means the scaling has been updated as against 2.0 that we had before. And if you check further, for example, this one, check this is 3.53. That's what's in the drawing. So I got 3.51. So the difference is 0.002. So this is still correct. So I said if I was getting 3.6 and this is 3.5, I was getting 3.7 and this is 3.5. So that means my scaling was wrong. But if it is still within this range, then I can say the scale is correct. So that's it for scaling of a page. So do we have any question as regard creation of projects, that's to upload the drawing and then to scale and dimension? Do we understand the processes?
So I've been able to upload the drawings, but I still need, to shed more light on the scaling and dimension. But I've been able to get to the point that I was able to upload the drawing, create a file, and then upload the drawing into the software.
Okay.
Yes.
So let's go through it again. The process of scaling is, let me delete this ones so that we can start it. So to scale, the first thing is you check around the drawing, then you decide on the value you want to use for scaling. And I said the value you should use should be a value that you can clearly see the start point and end point. You know, every dimension on this page has a start point and an end point. So for example, this value 3.7, this is the start point, this is the end point. This value 1.275, this is the start point, this is the end point. So we choose to use 3.7. So you can use any value on the page. So we choose to use this one. Then to scale, you click scale to on your toolbar. So this page has already been scaled. Let me use another page that is not scaled at all. Okay. Okay, so let's say I'm using this page now. So to scale, I'm just going to click, let's say I want to use 4.09. So I'll click scale. So when I click scale, I'll type the value 4.09. So the values in most drawings are in millimeter, but your scale should be in meter. Although you can choose to put your scale in millimeter. If you click this, there are options. But since most of your taking off will be in meters, so you can start the process from here. Everything should be in meters. So you convert the value to meters. 4090 converted to meter is 4.09. Then I'll click OK. And I take my cursor to the start point of this value. I'll left click, and I'll take it to the next point, which is the end point of this value. Then I'll left click again. So once that is done, I'll click dimension to measure another value on this page to check whether what I will get will be close to what's in the drawing. So let me use this to check. So I'm going to measure from here to here. So on the drawing is 2.23, but on my own measurement, I got 2.22. So I said if the difference between what's on the drawing and what you got in your dimensioning is less than is not up to 0.1, then you are correct. So if you check the difference between this and this is 0.01, 0.01, which is not up to 0.1. So that means we are correct. So that's how to scale. Hello, Ma. Do you understand it now?
Yes, I do.
Okay.
Yes, thank
So the
you.
next is let's learn how to use the length tool for measurement of length. So let's assume we want to measure the uh, foundation wall gut of this substructure. So we can use length for that. So when you click length, this comes up. So here you provide the name. So we can say this is foundation wall gut. So you can choose a color. So let's say I want to use red. I can change this to red. You get a default color, but you can change it. So going to use, once you click OK, it takes you back to the drawing. Then you start placing your cursor from the start point of your measurement. So I want to start from here. So I'll just place my cursor here. I'm following the center line. So when I position it, I'll left click, I take it to the next point. I'll left click again, take it down. I'll left click, have another wall here. So if you just like you are tracing. So if you want to take the external and internal together, then what you do is you right click. You can see new section and you can see continue. So new section allows you to stop from here and continue in a new section. So I'll take it to this point. And as I'm measuring it, it's adding the value. You can see the total is showing on the left part of the screen. So I'll use new section to continue. So you see currently the foundation wall is 56.4 meters, but if I do this measurement to this, it has increased to 66.9. So as you are measuring each wall, it is adding it up. So if you stop here, right click, new section. So, and it is giving the individual walls their length. So this one alone is 5.4 meters. So it also depends on how you place the positioning of your cursor. So that's how to use the software for length measurement. So we have slope length. There's difference between length and slope length. For example, uh, this is a staircase plan. You know that this staircase is sloping. And if you say the distance from here to here is 4.97 meters, so the slope length is not going to be 4.97 meters. The slope length is determined by the height. So in this case now, if we assume that the height that this staircase is inclined on, the height is, let's say, 2 meters. Then when we click slope length, it will ask us of the height. So we can say stair height or stair slope. Let's just call it stair slope. So the height, let's change this to 2 meters. So we can change the color to, let's say, blue. So when you click this, so if I should measure from here to here, this place to this place. So you see, this slope length, this length now that I got is 5.6 meters. Let me show you something else. So let me use dimension to still measure this. You see, when I use dimension, I got 4.98 meters. That's this 4.98 is the horizontal length, but the slope length is 5.36 because the slope length is telling you that this thing is inclined. It's inclined, and when it is inclined, it is not the same as when it is horizontal. So you can use slope length to confirm or to measure the slope length of any shape on the drawing. So on the drawings and measurement section, on the left section, you can also see the difference. You can see that for slope length, the symbol for slope is showing. For foundation guide, which is normal length, it is also showing. Okay, so the next we'll look at is area 2. So you can turn off the measurement of the previous ones you've worked on by clicking this light bulb. You can see the light bulb on the left side of your screen. So you can click this to turn it on, turn it off. So if you want to do another measurement, you need to turn it off so that it will not interfere with the previous one that you did. So to use the area tool, I'm going to click area, then I'll give it a name. So let's say I want to measure the ground floor area. Just say ground floor area. So I can leave it at this color. You click OK. When you click OK, it allows you to scroll, zoom in and position your cursor. So ground floor area is out to out of the foundation wall, not the excavation. We are not taking the excavation extent. We are only taking the wall extent. That's why I'm clicking on the edges of the wall. So that's another edge. So when I'm done, I'll right click and I'll say stop. So with this, you have measured the area. You can see the area is showing on the middle of the screen and it's also showing on the left side. You can see ground floor area is 131.01 meters square. And it is also giving you the perimeter, which is the length. The perimeter is 45.83. So if you have a shape that is not box like this, you can also use area. So let me just make assumption of, let me call this area 2. So let's say you have a shape like this. You just be clicking around the shape. As you are clicking, it will be taking the measurements of the shape. And you can also subtract from the area. For example, if I want to subtract from this area, I'll click subtract. Before you subtract, you click on the edge. You click on the edge of the area first to select the area. Then you right click. When you right click, you see subtract. You see currently the area is 9.42 meters square. So I can subtract, then I'll say stop. So when I subtract, the area has reduced to 8.94 meters square from 9 point something meters square. So that's how to use the area tool. You can use it to subtract from the section. So it's useful when you are taking your slab measurement. So when we get to superstructure, we are going to use that to subtract the opening before we take the total area of our suspended slab. Okay, before we continue, do you have any question on length measurement, slope length measurement, and area measurement before we continue?
Me, I don't have any question.
Okay. So let's proceed with volume. So we can use this for volume measurement as well. So when you click volume, this comes up. So let's say ground floor slab volume. So the depth is the thickness, which is, let's say, 0.15. So you can change the color if you wish. So you can use this for to get any volume. You know, the difference between area and volume is the thickness. Volume is equals to area times the thickness or depth. So that is what the software is also doing. So first, you measure the area. So when you measure the area, it gives you the volume. You can see the volume is 19.65 meter cube. So that's how to use it for volume. And if you check, the area is 131. So 131 times 0.15 should be 19.65. So this is what it does as well. Okay, so the next we should look at is the pan tool. So pan tool, like I said, you use it to move the page around, up, down, left, right. So when you click the pan tool, it shows a hand sign. You can use it to move the page around. In case you are doing a measurement and if for a very large drawing, you might get stuck in one part. So you can use the pan tool to move around. So the next we look at is, okay, zoom in is clear. You can use your mouse. If you are using your mouse, you don't need to use this to zoom in. So let's proceed to the prepare BOQ section. So to prepare the BOQ for this project, so we are going to prepare the BOQ and material schedule for this project. So let's start with prepare BOQ. You click prepare BOQ at the top. Then when you click, you can see another row of tools. So here you click work items. When you click work items, let's start with substructure. You click substructure. When you click substructure, you have two options, strip and pad and raft. So this is a strip and pad foundation. So you click strip and pad foundation. Then here you see other tools. So like I said earlier on, the substructure is categorized into the strip foundation details, the column bases, the ground beam, the regular column, round column, concrete wall, and then slab reinforcements. So let's start with strip foundation details. So there are some things we are supposed to measure. So we don't have site plan for this project. So let's assume an extent as our site area. So let me go back and measure site area. So let's say the site area is from here to here to here to here, then stop. So this is our site area. Okay. Then we're also supposed to measure the trench gap. So the trench gap is the line, the space between the column bases and your trench gap. So let's use our length tool to measure the trench gap. To use the automated BOQ aspect, there are some basic values the user is supposed to provide. And some of the values are you're supposed to measure your site area, supposed to measure the trench wall, sorry, the foundation wall guards, you're supposed to measure the trench guard, which is what I am doing now. So those are the four measurements you are going to take: the ground floor area, the site area, the foundation wall guard, and the trench guard. So once you take that four measurements, and you can use your measurement tool to take that, then you don't need to do any other measurement. So most of the other things are entry. You just type the specification of the drawing and the details of the drawing, and the other values will be calculated. So I'm taking the from here, I can decide to change the color also. So these steps also applies to complex drawing. I know this is a simple drawing. So even if you have a very complex drawing, it's still the same process. So if you can understand the process for a simple drawing, you apply the same process for a complex drawing. So even for complex drawing, the first thing is you establish your site area, you establish your ground floor area, you measure your trench wall. So this is the trench wall. Trench wall is you just measure all the wall in the substructure. That's your trench wall. Then the next is your trench, sorry, your foundation wall guards. You get your foundation wall guard. Then the next is your trench guards. So the trench guard is used for excavation for trench. So once you've gotten all that values, you go to prepare BOQ, work items, substructure, strip, and pad. Then you click strip foundation details. So when you click strip foundation details, you just fill this form. So this is more like you're just filling form like data entry. And the user interface has been improved upon to make it easy for the users to type. So the first is description. So you say site and trench description, then the area. So we've already measured the area. You don't need to type it. You can just click this import symbol. You can see this arrow pointing down. When you click it, it allows you to go back to your measurement and you just select the site area you have measured. So when you click site area from the left side, you click import. So you see it has imported the value, so you don't need to type it. So the next is the ground floor area. So the ground floor area is 131. So you can click this import and you just type this and you say import. So another thing is so the perimeter, you can get it from the area. If I hover my cursor again, you can see I have my perimeter, which is the length as 45.83. So if I go back here, so this one you need to type it 45.83 because it's not listed. Then trench guard, I've already measured it, so I'll just click import. So I go to here. So the next is wall guard. I'll click import. Then I'll say foundation wall guard. Then the next is the depth. So depth of this excavation. So let me check. So to go by, you click quick measure. So the excavation is from here to here is 1.2. From here is this. So what will be the total? Please compute this and tell me the total. This plus this is what? Hello, 1.2 plus 0.23 is what?
It's a 1.43.
Yes, so that's the trench depth.
1.43.
Yes, thank you. 1.43. So trench depth, we put 1.43. So the next, you see, there are some values that is already established by the software, like the trench width is predicted, the topsoil thickness is predicted. So you don't need to type everything. So you just go through them, the ones that are different. That, for example, if your oversized slab thickness is more than 0.15, you can change it. But if it is the same, you can leave it. So there's a lot of predicted values here. So I can just go ahead with all these. I'll just click enter. So when I click enter, the software has done a lot of calculations for me. It has given me my site area, my topsoil uh, excavation, my trench excavation, disposal of topsoil, disposal of surplus material, leveling and compacting, earthwork support, anti-termite, backfilling, laterite filling, rock filling, blinding, oversight, slab, concrete volume, trench footing concrete, formwork to edges of slab, reinforcement, trench block work, damp-proof membrane, and so on and so forth. So we have all these values, and as he's doing it, he's sending it to the bill. So if I go to default BOQ, you can see I have them in my bill now. Can you see the BOQ? So as you are working, the BOQ is being updated. So this is the BOQ for what we have done. So the ones that we have not done, you see the value as zero, like column-based concrete, you see zero because we've not done column bases. So and you can export to Excel when you are done. So the next is column basis. So we click column basis for that. So when we click column base, so for this project, so to go back to your drawing, you just click quick measure. So for this project, these are our column bases. So we have BT1, BT2. So let's use count 2. So let's go to home and use count. So we did not learn how to use count, so let's learn it now. So when you click count, you have BT1. So you just be clicking wherever you have the count. So we are done with BT1. You right click and stop, then you click count again for BT2. This color is not visible. Let me change it. So BT2 is just 1. So when you go to column basis, you can see the dimension. BT1 is 1.2 by 1.2, BT2 is 1.4 by 1.4. So like I said earlier on, even for a complex drawing, it's still the same procedure. You count all the column bases. You can have BT1, BT2, BT3, BT4. You do it individually. So, and even before you type the name, you can put the description there. BT1 is 1.2 by 1.2. BT2 is 1.4 by 1.4. So I can right click and edit. I can say BT1 1.2 by 1.2. Okay. Then I can click and edit. BT2 is 1.4 by 1.4. Okay. So all the column bases, they are Y12. Okay, sorry, this is Y16, Y16. The center to center for the reinforcement is 0.2. And the excavation, the column base thickness is 0.3. The excavation depth now is 1.5. 1.2 plus this is 1.5. So let's go back to the prepare BOQ. So we've gotten, can write down that the reinforcement is Y16 at 200 center to center. The depth is 1.5 meters. So when you go back, you click prepare BOQ, you click navigate back to column basis. Okay, so let's check. The reinforcement is bottom only. BT1 is bottom only, BT2 is bottom only. If it is top and bottom, you will see it from here. As this one is like this, there will be another one at the top. So this is also important. So the default is bottom only. So you leave it as bottom only. Description, you say is type 1. The length is 1.2 by the breadth is 1.2. The excavation depth is 1.5. You can see the blinding is already predicted. The column base thickness is predicted. You don't need to type. The concrete cover is predicted. You don't need to type. The reinforcement bend. So you can see the default reinforcement is Y12. So you can change it to Y16. And you take note, as I change this one to Y16, the next one also changes to Y16. The spacing is predicted. So the number, so for BT1 is 13 number. So I can just type it, or you can use import if you don't want to type. Then once you are done, you click enter. So when you click enter, it gives you your excavation for that column base, leveling and compacting, concrete, and then reinforcement. If you scroll to the right, you see the formwork and reinforcement. So you have your total reinforcement. Total reinforcement for kg for the length side and the breadth side. So let's add another one. So we have BT2. So BT2 is 1.4. So you change the description to BT2. The length is 1.4. The breadth is 1.4. So the other values are the same, only the number. So I change the number to 1. So this helps the users not to type too much. You just change what is peculiar to this item of work. Then you click enter. So with this, we have BT1, BT2. And you see, it's giving you the total. Excavation, BT1 plus BT2. The total is this. Leveling and compacting, BT1, BT2, total is this. Blinding, 1, 2, this is the total. Reinforcement, and so on and so forth. So if you go to your bill now, you can see, if you scroll down to where you have column basis, you see that for excavation, you have a value for, you can see this is column-based excavation for BT1 and BT2. If you go to concrete, you can see we have for blinding for column base, we have column base concrete, we have reinforcement, formwork to column base, you can see you have reinforcement for column base. So as you're working, the bill is being updated. So the next is ground beam. So although we don't have ground beam for this project, but let's let's assume we have a ground beam. So let's say the ground beam is description is ground beam 1. So for a project, if the ground beam has the same length, sorry, if it has the same depth and width, let's assume that all the ground beam in the project is 230 by 450. Then you can just take the GAT together. So let's assume that this GAT is also for our ground beam. Okay, so if that is the case, then you should go to ground beam. So, but if you have a project that has ground beam, then you use your length, you go to home, you use length, you go to the ground beam drawing and you use length, this length 2, and measure the total length. So when you measure the total length, you come to your ground beam and you use the first option, concrete works substructure. Then you type the length, or you can use imports. So let me just assume that this foundation wall GAT is the same as the ground beam GAT. So I'm using this as my ground beam length. And I say the ground beam is 230 by 450. So you see the stirrup length is calculated, the stirrup spacing, the stirrup diameter, and so on and so forth. So the beam bar diameter, so let's assume is Y16 as well. Number of bars, let's say it's 4Y16. Number of beam is 1. And you click this. So with this, you have your beam, concrete, formwork, reinforcement, and stirrup. So the reinforcement is given in meters and in kg, but the one sent to the bill is the one that is in kg. So you are being given in meters in case you want to use the value for some other analysis. Then you have your stirrup and your surplus for disposal. Then we have another ground beam reinforcement here for a scenario that some of the beams have a lot of different types of reinforcement. The scenario we gave here, where all the reinforcement, they are all Y16. Okay, so let me also use this opportunity to show you how to edit. Let's assume that you've done this one now, this ground beam, and you notice that, oh, the reinforcement is supposed to be Y12 and you use Y16. So you can click this. You can see when you click this button, this green button has changed to cancel updates. So before you click cancel updates, you make the correction first. So let's say I want to edit this reinforcement to Y12 and there are 6 numbers. So once I'm done, you see as I'm changing it, if you take note, the reinforcement is being updated. Please take note, currently the reinforcement is 473, that's in kg. If I change this to 4, see it has changed. So I can do this update, then I click cancel update. So when I click cancel update, it has recorded the updated version of my work. So that's how you use this to edit. So even the ones that you've done before, like the column base, if you made a mistake, instead of you can also delete. Actually, if you scroll to the end, you see the delete. You can use delete to remove. But if you don't want to delete, you just want to update, you can click this. Let's assume the number is not 13. You can change the number and then you click cancel update. So as you are changing it, the value will be updated. But when you click cancel update, the one you worked on, you updated, will move down to the so you see if I click cancel update, number 2 has gone down again. So that's how to edit what you've worked on before. So I was talking about the second option of reinforcement, of beam reinforcement, is where you have different reinforcement in a beam. So let's say you have beam 1, for example, and you take the length of the reinforcement. Let's say the length of beam 1 is 20 meters, and in that 20 meters, you have Y20. So, sorry, the beam 1, the length of Y20, let's assume is 14 meters. You can also use your measurement tool to measure it. And when you measure, you can use this import to import the value here. The number of bars, let's say this Y20 is 4. Number of beam is 1. So let's say this same beam 1, you have Y16 in that bin one, and the length of Y16, let's say, is 8 meters. You have Y16. How many Y16 do you have? Let's say it's 6 numbers. So like I said, you can use your measurement tool to measure it from the beam. But if all the reinforcement in the beam, if they are similar, just like we did here, we just took make assumption that they are all 4 Y12, then it will give us the total value. So for columns, so this is regular column. So we have regular column and round column. So the total column in this project is it will be 14 because the column bases are 13 plus 1, that's 14. You can also use count 2 because in some cases, one column base can have 2 columns in it. So you can use, if you want to use your count tools to count just the column, you can say columns. So you can as well use this to count the columns separately. So stop. So for columns, you can say they are C1. The height of the column in substructure. So let's check the drawing. This is the height of column in substructure from the top here to here is 1.2. So if we deduct the slab from 1.2, what are we going to have left? Hello? The slab is 0.15. 0.15 from 1.2.
It's 1.0, 1.05.
1.05. So let's
1.05.
okay, thank you. So let's just take it as 1.1. So 1.1, the length is 0.23, that's 230 by 230. Breadth is 0.23. The number of column is 14. So you can use this to import the value if you don't want to type, or you can just type it 14. The spiral spacing is 0.2. We did not check. The reinforcement is for the columns is what? Is 4Y16. So we have column 1 as 4Y16. We have column 2 as 6Y16. Okay. So that's the difference. So column 1 is 4Y16. So the column diameter is 16. Number of bars is 4. So column 2 is the same. 1.1, 230 by 230. The number of columns for column 2 is 1. And the number of bars is 6. So we just change what is peculiar to this one. So then you click enter. Okay, but there's something we did not confirm. There's what we call the column bar length. Okay, the column bar length you can see is telling us is 2.3. So it's adding 1.2 to the height of the column. So let's confirm that if that 2.3 is accurate. So yeah, we can say if you are using this as reference, if you take from here to here, that will be 1.5. If you add this bend is 0.2, that's 1.7. 1.7 plus, let's take this projection to be 1 meter, that will be 2.7. So 1.7 plus 1 is 2.7. So let's say our reinforcement is not 2.3, it's 2.7. So you click enter. So the first one we did, column 1, we use 2.3 as the reinforcement That's the column bar length. So let's update it. So you see the way I just click this, then I can change this to 2.7, then I'll say cancel update, then it will bring that down because that's the one you just worked on. So again, this is how to use the edit for the or previous works that you've done. Okay, so this column reinforcement, regular column reinforcement. This is if you have a column that has mixed reinforcement in it. So you just use this to, let's assume that column one, you have a mixed reinforcement in it. So you treat the reinforcement one by one, the diameter, the number of bars, the number of columns, then it will be calculating in meter and in kg, and it will add it to the one that you've already done here. But in this case, we have Y16 all through, so it's not a mix of reinforcement. So round column, although we don't have round column in this project, but let's just assume we have two round columns. So let's say we have C3 as our round column. So our column in foundation height is 1.1. So you can see the round column is radius it is requesting for, not length and breadth. So we have the radius as this. The number of column, let's say, is 2. The other values, so let's say our starter bar is still 2.7. You can see the stir up has been predicted as well. The reinforcement is Y16. Number of bars, let's say it's 6Y16. Click enter. So let's say we have two round column C3. So it gives you the concrete formwork reinforcement. The concrete wall. If you have concrete wall in a project, you measure the length of the concrete wall using from the drawing using your length tool. So the default bar type is double. So we have double and single, but most concrete walls are double bar. But if the one you're working on is single bar, then you change this to single. So let's say this is C wall 1. So the height, so let's say the height of the wall is also 1.1. Let's say the length of the wall is, let's say, 8 meters. Then the reinforcement is Y12 in the horizontal. Then the bar spacing is 0.2 by 0.2. The number of wall is 1. So you click enter. So with this, you have your concrete formwork reinforcement for the wall, concrete wall. So these slab bars, you use it if you have a suspended slab in the substructure. So here you provide, but we don't have suspended slab. The slab we have is the ground floor slab. So if you have suspended slab, you put the area of the slab, the perimeter, the reinforcements, the spacing, the average return, and then the number of slab. So if you click this, it will give you the reinforcements for that slab. So let's just assume that we have a slab of this area is 131. So let's say 131. Perimeter is, let's say, 45. The number of slab is 1. So you see, this gives you only the reinforcement. So it has calculated the reinforcement for us. So with this, if we go to our BOQ default, you can see we have the BOQ for this. So I can collapse this so that I have a better view. So some items like counting of trees. This is trees. I don't have trees here, but if I had counted it, I can just click this to import the values. Okay, let me make assumption for these trees. So let's say, yeah, let me call this trees. So let's say I have this one too. So if I'm on prepare BOQ default BOQ, so you can click this to import the trees. So you see the value has been imported. So if you have counted it, you can import, or you can just type. So let's say this one is 4 numbers, this one is 2 numbers. So our site clearance is giving topsoil excavation So this is for raft foundation. That's why it's blank, because we don't have raft foundation for this project. Then this is the trench excavation guards. Sorry, trench excavation volume, column-based excavation volume, earthwork support, disposal of groundwater. We don't have groundwater here. So disposal of materials, disposal of topsoil, backfilling, laterite filling, rock filling, damp-proof membrane, anti-termite, leveling and compacting, trench, footing, concrete. So these are concrete work. We have for trench footing, we have for blinding, we have for ground floor slab, we have for column bases, we have for ground beam, we have for column starter, we have for concrete in concrete wall. Then these are form works. We have form work in column bases, form work to slab edges. We have ground beam form work. We have form work to regular column, round column, and concrete wall. Then these are the reinforcements. The reinforcement are in kg. Reinforcement in column base, ground beam, slab reinforcements. Although this is mesh, but we just added this, making assumption that it has a suspended slab. But if normally for this project, this should be blank, but we did something there. That's why it's showing. Column starter reinforcement, concrete wall reinforcement, stirrups, ground beam, and mesh. Then we have block work in substructure and plastering of the edges of substructure. So this is the substructure items that has been done. So if you click material and labor schedule, you can see it will also give you material for these substructure items. So you can see earthwork support, this the timber you need in numbers, and the brazier. Laterite, this is sorry, the laterite. Okay, this laterite and rock is not showing, so check why it's not showing and update it. So, but the improved membrane, you can see it's showing. Check that down. So your anti-termite material is showing. So for your footings, trench footing is showing the cement, sand, and gravel. Line. So the materials for column base, ground beam. So some of these materials are not showing. So this will be updated. So when it's updated, if you're connected to the internet, your own version will be updated as well. So this is for block wall. You can see the number of block wall, the cement and sand for mortar that is needed. So this is for plastering. For plastering, you need cement and sand. For painting, you need just paint. So this is the superstructure, starting with beams, then columns. So I'm going to have a 30 minutes break where I will also allow those that have their own to to practice. Then after the break, we can start the superstructure. So do we have any question before we go for the break? Hello, do we have any question?
We'll practice maybe before then. We'll get back to you, sir.
Okay, thank you.
Yes, sir.
So we convene by 12. Hello, can anyone hear me?
You can go ahead.
Okay, sir. So welcome back. A recap of what we did before the break is we learned how to create a new project. We also discussed the different tools in the software and their functionalities. Then we learned how to use the scale tool, the dimension tool, the length, slope length, area count tool, and volume tool. We learned how to use the pan to zoom in, zoom out. And then we learned how to use the length for measurement of guards, uh, such as foundation wall guards, trench guards. Then we use the area tool for measuring the ground floor area, and the count tool for counting column bases and columns. Then we proceeded to preparing the bill of quantities for the substructure for this project by using the prepare BOQ page, clicking work items, substructure, and the different sections of the substructure. The straight foundation section, the column base, the ground beam. So we did all this by typing the values that are related, and some of the values have been imported from the measurements that we have previously done. So now we are proceeding to superstructure. So for today, we look at the beams, the columns, the upper floor, the wall, and wall ties. Then tomorrow, we'll treat different types of roofs. We'll start with a simple roof, then we'll do a complex roof as well, and then we'll also do M&E tomorrow. So for today, we are going to cover some items in the superstructure. So we are starting with beams. So like I said earlier on, that though this project is not a complex project, but I said the approach you use for this, the same approach you use for the complex ones. So we are starting with the beam, superstructure beam. So this page, we've already scaled it, so no need to scale it again. But in your own case, you can scale afresh. Then after scaling, to measure the gaps, so we just need the gaps for this beam because all the beams are the same. So, but in a case that you can have different types of beam, then you need to measure the gaps for each of them separate. So maybe we can make such assumption in this case. So let's say we have two types of beam. We have 230 by 450 beam, and then we have 230 by 600 mm beam. So let's start with the 230 by 450 beam. So we can say 230 by 450 mm beams. So let's give it a blue color. So let's say this are the 230 by 450. So I'm using my length tool for the measurements. Right click new section because it's continuous. New section. New section. New section. New section. New section. Okay, so this is all the beams. So let's assume we have another one, 230 by 600. So let me say this is it. So let's assume that the 230 by 600 is located here and here as well. So this is how you use it. If you have another beam, let's say you have 230 by 900, you click length again, you give it the appropriate name, and then you use your length to measure the length. So now, when you go to, please, can everyone hear me?
Yes, we can.
Okay. So when you go back to prepare BOQ, now you click work items, you click superstructure, you click beam concrete works. So we have our two types of beams. You can say this is beam 30 by 600. The length is, okay, the length, you can click this. Okay, sorry, let's start with 230 by 450 mm. Then let's click this length to import the value, which is this. So you click this and then you click import. So you can see the value has been imported. Then the other items are already predicted by the software. So if you check the drawing, the reinforcement for the stirrup reinforcement is Y10. Okay, so let's check what's the dominant reinforcement in all the beams. So the dominant reinforcement is Y16. What's the number? 4Y16. So most of the beams are 4Y16. So this is 4Y16. This is, most of them are two reinforcement at the top, three reinforcement at the bottom. That's 5Y16. So we are using 5Y16 as the number of reinforcement bars. So the beam bar diameter is 16, number of bars is 5. So 5Y16. Click enter. So the next is beam 230 by 600. So the length is 10.42. As you can see, you can just type it 10.42. So the reinforcement is also, let's say this one is 6Y60. 3 at the top, 3 at the bottom. Then you click enter. So we have beam 1 and beam 230 by 450 and beam 230 by 600. So the concrete, the formwork, the reinforcement, and the stirrup is calculated. So for all the quantities, it will be summation of beam, the first beam and the second beam type. So the total that will be sent to the BOQ. So then we have columns. So we have regular column and round column. Okay, so if for the beams, if you want to be taking it reinforcement, if you want to be taking it beam by beam, in some cases where the beams are very complex and they have different, you can see one beam, you have like 4 different types of reinforcement in the beam. So what you are going to do in that case, you scale each of the beam. Sorry, you scale the page and measure each of the beam. So in this case now, I'm going to scale this. So please take note, I'm just giving you another scenario. So you're not going to use both scenario in a single project. So I'm just giving you a scenario that the beam is very complex. I'm showing you how you treat it. So let me use dimension to check this. So if I want to measure this, let's say we have a reinforcement, uh, or maybe tomorrow I'll get another drawing that has a beam with different reinforcement. So we'll use that. I will join that as part of what we learn tomorrow, because this one does not have different reinforcements. So let's just take this as a project that has all we can say the reinforcements are the same. So, but even if, let's say your Y12 is very little and Y16 is the majority of the reinforcement, you can take Y16 as all the reinforcements. So let's proceed to columns. So for column, we have the numbers of column already established earlier on. So we have column 1 as 13, column 2 as 1. So let's start with column 1. So before we proceed, let's study what we have in the section. So you can see we have column 1 is 13 number, and we have column 1 in the ground floor and first floor. Column 2 is 1 number, and we have column 2 in the ground floor only. So remember, the superstructure is from ground floor and other floors at the top. So for column 1, the reinforcement, the column 1 is 230 by 230, and number of reinforcement is 4y16. Column 2 is 230 by 600. Number of reinforcement is 6y16. So let's start with column 1, 4y16. The spacing is 175 mm, y10, as you can see. So the height of the column is, who can tell us what's the height of the column? Hello?
As seen on the drawing side is 3.15.
Oh, that's if you add the beam, it's 3.15.
Okay.
So you deduct 450 from 0.15 because this is taking it to the top of the beam, which is the top of the slab, and the slab and the beam are together. So it will be this is for the column concrete. The height of the column, the concrete in the column is 3.15 minus 0.45. So it's 2.7. But if you are saying the reinforcement in the column, it will be this 3.15 plus projection. So if projection is 1 meter, it will be 4.15. That's for the reinforcement in the ground floor. But reinforcement in the upper floor, it will be 3.15 plus a bend of 0.2. So it will be 3.15 plus 0.2, that's 3.35. Why the height of concrete in the column for upper floor, it will be 3.15 minus, this is not up to 0.45. So this is, let's say 0.3. This is a roof beam. So let's see if they have roof beam. Okay, I think this is the roof beam. The roof beam is 350. So it's going to be, so the height of the concrete in column is going to be 3.15 minus 0.35. So that's 2.8. So we are going to treat it floor by floor. So let's start with the ground floor. So we can say ground floor, we have 14 columns. No, ground floor, column 1, we have 13 columns. So let's take it like that. So that will be more accurate. So C1 GF, that's C1 in column 1. The height is 2.7. That's the column height, 230 by 230. Number of columns is 13. The this is height of stirrup portion. Okay, you can see a bit like that. But the column bar length for C1 in ground floor is not 3 point. It's not 3.9. It should be 4.15 because it's 3.15 plus 1 meter projection. Do you understand how I got 4.15?
My mic is on.
Hello? Do we understand how?
It's clear. Let's
Okay.
move ahead.
So the number of bars is 4. So you click enter. So C1 GF, you've gotten the concrete formwork reinforcement and stirrup. Then C1, okay, let's move to C2 GF. That's C2 ground floor. C2 GF is 230 by 600. Then the number of column is 1. The number of reinforcement is 6 twice 16. So these other ones are the same. So the next is C1 FF. That's C1 first floor. The height is 2.8 from our calculation earlier on. That's 3.15 minus 0.35, 2.8. But our reinforcement is going to be 3.15 plus 1 because there's no projection. So we have 3.35. So let's say 3.4. And C1, remember, is 4y16. So number of bars is 4. So we don't have C2 in first floor. So these are the 3 types of columns we have in this project. So the concrete formwork reinforcement and stirrup is calculated as follow. So with this, we are done. So we don't have round column, but the round column is similar to what we did in substructure. So if you understood what we did in substructure, it's the same thing. So the whole process is more of you are entering the specification of the items, and it helps you run the calculation for each of the items and gives you the quantities associated. So let's just make an assumption that we have C3. Let's say we have C3 in the ground floor. Let's say it's 2.7 also. The number of column is 2. The bar is let's say it's 4.15 as well. Or if it terminates at the ground floor, then it should be 3.3, and that's 3.4. Number of bars 6. So with this, you have your round column. Round column is just the radius that's being considered. So if your radius is 0.45, you can edit, or you provide the correct value before you click enter. So the next is upper floor. So for upper floor, we go back to the upper floor reinforcements. Okay, let's use this for the upper floor. So let's use this to scale 0.7. It's a new page, so I want to scale again. So then let me measure the area. So for the upper floor, I need to measure the area, then I'll check the reinforcements. We have a majority of Y12 and the spacing is 200 and it is top and bottom, as you can see. So measure the area, then you deduct the stair section. So let's say this is first floor area. So let me give it very clear color. Let's use this. So the area measurement is, as we already know, you click on the edges. You right click and you stop. So now let's deduct the staircase section. So remember I told you to deduct, you click on the edge first before you right click, then you say subtract. Then let's subtract this staircase. So you see, before we deduct, it's 131, right? So, but after we deduct it, it should reduce. So now we have 122. It deducted minus 8.89. So,
So I'm sorry. Can you repeat that this deduction where we touch first before we whether right click or left click?
okay, sir. So let me delete this one. So to deduct, you can see this area that we measured, it has a border line. So you first of all you right click, sorry, first of all you select the border line by left clicking once. So when you left click, that's you select the line. Then after you select the line, you right click. When you right click, you can see these options. Then you click, you select subtract. Is that understood?
Yes, go ahead.
Okay, sir. So then you just click on the point you want to subtract. Then you say stop. So with this, it has subtracted. You notice the first time I did it was 8.89. Depending on how I position my cursor. So the positioning of your cursor also affects the subtract portion. So my effective area now is 122.6 meters. So and the perimeter is 45. Let us say 46. So go back to work item superstructure. So let me check the perimeter again, 45, 46. So for the slab area, I can use imports to select this import. Then the perimeter is 46. So the opening perimeter. So let's check the opening perimeter. Let's use length to measure the opening perimeter. So that's 12.87. So opening perimeter is 12 point, let us say 12.9. Number of slab is 1. So this is first floor description, first floor slab. Say enter. So you have the concrete formwork reinforcement for the slab. So if you have other slab like second floor, third floor, and they have different area, you do that accordingly. Then the quantities will be a summation of all the different slabs that you've worked on. So the next is so I said we work on roof and M&E tomorrow, and we also look at a beam that has different reinforcement in it. So those are the 4 items we work on tomorrow. So let's go to block wall. So for block wall, we need the architectural drawing. So let me show you how to add a drawing. Let's assume we started this, then later on they sent us the architectural drawing. So this is what we do. You can see this green plus. So when you click the green plus, it allows you to bring in the architectural drawing. So it's the same process as creating a new project. So I have mine in project drawings, then So when I expand this, I have added architectural. You can see, uh, sorry, this is still the structural. Let me add the architectural to the folder so that we can proceed with that. Okay, so I've added it to the folder. So when I click this, you can see the architectural is showing now. So I only want to add architectural. So I'm going to check just this box beside architectural, then I'll click confirm. Then to start importing the pages in the architectural drawing file into the work section. So it's almost done. We are 84% now. Okay, so we've added the new pages. Scroll down, you see them listed under. So this is the architectural. So we need the architectural for the block wall because we need the external wall guards and internal wall guards. Then for the wall ties, we need the to get the sections where you have toilets and kitchen to measure the guards as well. So I'm going to scale because this is a new page. So let me go to this to scale. So I can use 0.9. Remember I said you can use any value to scale. So I've scaled, then you confirm with dimension, then you use length after that. So let me start with external guards, ground floor. So let me do center to center. So stop, then let me say internal guards, GF. Choose something else. So new section, we use new section to stop the current work and continue it in another place. So the difference between new section and continue is if you click continue, it allows you to just continue. But meanwhile, we are supposed to stop here. So it's new section we are going to use. So we say new section. Okay, so we are done with the internal walls. Then we say stop. So the next is this is for ground floor. Yeah, ground floor. Then let's do for the first floor. So let's scale this as well. We can use 1.2 for scaling.
Please, what of if the blocks are different? They're like 150 and 225. How do we demarcate those ones?
Okay, if the block wall are different, then you take it separately. So you take the guts for 230. For example, it mostly occurred in internal wall. If you have it in internal wall, okay, I think we should have it here. Or when we are doing this one, I will show you, we'll make assumption that we have some wall that are 150. We take those ones separately. So for the external guards, let's just assume the ground floor and first floor is the same. So let's say internal guards 230 mm. So let's say this one's so let's assume this one is 150. So you need to click length again and say internal guards. This is first floor, 150 mm. So you measure them separate. So let's say this is 150 mm. Let's say this is, although this is 230, but we're just making an assumption. So let's say this one too is 150 mm. So when you stop, if you want to continue this 230 that you've done before, you click any of the 230 that you've done, any of them. When you click, you left click first to select. Then after you select, then you right click, then you say new section. Because if you say continue, it will continue from, you see, this is where I stopped initially. So it allowed me to continue. So, and if you made a mistake, the way I did now, and I want to take it back, I will use Control Z on my keyboard, Control Z again. It allows me to go back. So what I'll do here is to left click to select, then right click, then I'll say new section. So that's how to continue. If you have stopped and you want to add to what you have done before. So let me edit this one to add first floor. Okay, we've gotten the needed values. Then we'll go to wall, external wall. So external wall, you write the description. This is external wall GF. That's ground floor. So the guards, click this to import external wall GF, import some. Then the height. So let's check what's the height from our section. So you can see from here the height is 3.3. Okay, this is more appropriate. So this is 3 meters from the ground floor to the bottom of the surface of the slab. So we can say the wall height is 3 meters here. It's also 3 meters in the upper floor. So we can continue with 3 meters as our height. Then the number of projects is 1. So the default is chained lintel for the external wall. So the lintel is, the depth is 230, the number of reinforcements. So let's assume it's 4 reinforcements. Our Y12 diameter, the length, startup length is 0.92. Then the spacing is 0.2. The startup diameter 8 mm. And openings. So we are going to add openings for the external wall. So what are the openings that we have here? Let's turn this off. So we have window 2, window 4, window 3, window 1. 1, 2, 3, 4. So let's count. So the approach should be, you measure the guards, you count the windows before you proceed to imputing the values. So I have window 1 counted, and the next is window 2. So window 2 is 600 by 600. So window 1 is 750 by, okay, let's check it has a schedule. But from here, we can see window 2 is 900 height. Window 3 is 1.8 meter height. Okay, so this is the door schedule. So we can rename it so that we can locate it faster. Remember, I told you to rename, you double click, you type the new name, you hit enter. So for this is door schedule, you double click, say door schedule, and you click enter. So our windows, window 1 is 750 by 1.8. Window 2 is 600, that's 0.6 by 0.9. Window 3 is 0.9 by 1.2. Window 4 is 1.2 by 1.5. So let's check the doors as well. Door 1 is 1.2 by 2.1. Door 2 is 900 mm. Door 3 is 750 mm. So for the counting, you can update what we did. Window 1, let's add the dimension 0.75 by 1.8. So this is for ground floor. The next is window 2. Window 2, 0.6 by 0.9. So let's count it by clicking where we have those windows. Then window 3. Window 3 is 0.9 by 1.2. So we have window 3 here. So this is window 2 that we missed. So you click any of the previous window 2 that you've done. Like this one, you right click and you say new section. You click this one to add it. Say stop. So the next is window 4. Say window 4 is 1.2 by 1.5. Okay, so we are supposed to add window, let's say GF window 1, so that we know that these are all for ground floor. GF window 4. So all these are for ground floor. So the next opening we have on the external is we don't have any other opening because this one has entered the internal, this door here. Because we took this wall as part of the internal wall. Okay, there's an opening here. So because there is no wall here, so we took it as an opening, except if. Okay, let's take this as an opening. So let's say this is Act 1, Act 2. This is 900 as shown here. Then this is 1 meter. So 0.9 by 2.3 and then 1.02 by 2.3. So this is an opening. This red line is the external wall, which from here I just click external guards and you can see the line showed back. So this opening we need to consider it, and this one also. This door is considered as part of internal. So this one also, there's an opening that we took here as another arc. So this is 1.5. So we don't have any door that is considered as part of external opening, but we have arcs. So we have 3. This is the first one, 1.5 by 2.1. Sorry, by 2.3, because it's usually higher than door. This one is the second one, 0.9 by 2.3. This one is the third one, 1.02 by 2.3. So with this, we go back and impute the values for the openings. So we click select opening window. So we start with window 1. Window 1 GF. Window 1 GF is 0.75 by 1.8, and the number is 6 numbers. So you can either type or you can use this import also. You say import 6 numbers. Then you click add opening. So when you click add opening, it will calculate the area. So you can use this to adjust this. So you have another window, window 2. Window 2 is 0.6 by 0.9. The number is 8. Change this to 8. You say add opening. Then window 3 is 0.9 by 1.2. The number is 5. You click add opening. See, it's adding. Then window 4 is 1.2 by 1.5. The number is, from here you can see it's 2. You click add opening. So another opening that we have is an arc, which you can say A1 0. The first one is 1.5 by 2.3. It's one number. You say add opening. That's added. So if you are, as you are scrolling, you see the list of the openings. So you say A2, which is the next one is 0.9 by 2.3 by one number. The next one is A3, which is 1.2. No, sorry, it's 1.02, one number. So these are all the openings. So once you've added all the openings for this external wall ground floor, then you click finish. So again, the process is you provide the wall details here, the description, the guards, the height, then this for external wall. External wall is assumed to have chain lintel by default. So you provide the lintel details, then you add all the openings by selecting the type of opening first. So we started with windows. We've added all the window 1, window 2. For each of them, you provide the details, you click this button. So we've added all the openings. And when we are done, then we click finish. So when we click finish, if you click this next tab, external wall details, you can see the wall area has been calculated with the finishes, then with the lintel. The lintel is also calculated. So this wall area, it has deducted the openings. So to see the openings again, when you click this, if you scroll, click to the next tab at the top, you can see the openings that was used to generate this. So this area here is this value times this value, then deduct all the openings that you've entered. So that's what gave you this final value here for your external wall. This is for ground floor. So let's do for first floor. So let's change this to external wall first floor. So they are still the same. They are the same guards, but the the openings will not be the same. So let's check the openings for, so let's say window 1, first floor. So we have window 1 here. So you say stop, then we have window 2, first floor. Then we have window 3, first floor. Then we have window 4, first floor. So these are all the windows. So let's proceed to enter the values. So the guards is the same. So let's start with window. Let's say window 1, which is 0.9 0.75 by 1.8. The number is 4. So you click add opening. Then we have window 2, first floor. The value is 0.6 by 0.9. The number is 3. Click add opening. Then next is window 3, first floor, which is 0.9 by 1.2. The number is 6. Say add opening. Then window 4 is 1.2 by 1.5. The number is 1. Say add opening. Then when you are done, you click finish. So here we have details for window external wall and for both cases. So for internal wall, we've done the GAT. So you can see the GAT is 48.85. So we put the description, internal wall, so we say 48.85. Put the height. So the opening for internal walls, the lintel is usually separated. So we change it to separated. So the number of bars is 4. Then the openings. So we select the opening. Usually have doors for internal wall. The openings are usually doors. So if you check this, we have door 2, door 3, door 1 also, because if you check the guards, this door 1 enters the internal. So door 1 is 1 number, door 2 is 1, 2, 3, 4 numbers. So we can use that count to get the numbers as well. So let's say door 1.2 by 2.1, 1 number. You say add opening. So you can drag this up to see what you are doing. Then door 2 is 0.9 by 2.1 and it's 4 numbers. Door 3, 0.75 by 2.1. So let's assume this is 2 numbers. Yeah. Then when you are done, you click finish. So the values here are after deduction of openings for the separated lintel. So if you click this, you can see for each of the door, the concrete and the formwork and reinforcement is being calculated as well and styro. So we will do the same thing for the first floor internal wall. So when you finish, you also you add all the openings and click finish. So that's how we handle the block wall aspect. So the next is ties, wall ties. So for wall ties, it's still similar. We normally have wall ties in toilet and kitchen. So let's take the GAT first. So you use length to measure the GAT. So because of time, we just make some assumption because we have just 5 minutes left. So let's say you measured this section. So we have kitchenette, closet. There's no wall ties there. So we have another one here. We have another one here. Okay, so the wall ties is 18.4 meters in total. So let's say for the ground floor and first floor, let's say it's 36 meters. So you use the length as 36, the height is 3, then you add openings. So we have the ones there are window 2, which is 0.6 by 0.9, the number. So let's say there are 6 numbers. You click, then door 3, 0.75 by 2.1. Let's say 6 numbers as well. Add opening. Then when you are done, you see we have 2 openings. Then you click finish. See the opening area and the reveal is being calculated. You click finish. So when you click finish, the effective area after deduction of opening is given. So now if we go to our default BOQ, we'll see quantities in superstructure has been added. So if we scroll down, you can see we have this is where the superstructure starts. Beams. You can see your concrete volume in beam, concrete volume in column, formwork in beams, formwork in columns, regular and round column, reinforcement in beams, reinforcement in column, then stirrups in columns and beams. They are in kg. Then we have the upper floor slab. We have the concrete formwork to edge, formwork to soffit, and reinforcement. So we've not done roof. That's why the roof section, roof beam and others are 0. So we'll do roof tomorrow. So this is the external wall, lintel, formwork, and the block wall. So that's external wall, internal wall, and then the windows and doors. So for the windows and doors, you can use this to import. For example, we have windows in different sections. So this is how you do it. When you click this import, it takes you back to the drawing. So let's say window 1 is let's assume window 1, although our own window 1, the description is different. Window 1 is 750 by 1.2. So let's just say window type 1. We have it here in ground floor. So this is the beauty of it. You can sum values of windows in different pages. You know, we have it in the ground floor page and in the first floor page. So as I click this, I can proceed to the first floor page and click this. You see, it has added it. So here we have 6, here we have 4. The total will be 10. So when I click import, I have 10. So window 2, we have window 2 in ground floor. I have window 2 in first floor, I import. So window 3, I have window 3 in ground floor, I have it in first floor, I import. So and so on and so forth. So we have window 4, so you can click this to add. Okay, this is where you click to add another section. So let's say this is 1.11. Let me check. The reference is 1.1.1. Okay. So this is how you add another row, 1.1.1. Then let's say this is window 4. 1.2 by 1.5. Number, that's the unit. So when you click add, it allows you to have another row. So with this, you can also import your window 4. Window 4 is here, window 4 is here, you click. So you have your total window 4. So the same applies to door. You can also click this to import the values. So we have our ceiling, the finishes to the block wall, and you see the wall ties is being calculated, the reveal and the wall tie area is calculated. We have our painting, plastering and painting. Okay, so for these floor finishes, these are values that you measure using your area tool to measure the floor type. So we'll do this tomorrow as part of what we work on. So this is ceiling finishes. So M&E, we have the M&E section here. Okay, so we are going to stop here for today because of time. Thank you very much for your participation in this training. So let's take questions. Do you have questions?
Okay. Yes, I have a question. Well done. Please,
Thank you, ma'am.
and how soon will you send this record, the first day recording?
Okay, in the next 30 minutes, you will get it.
Okay. Then how about you talked about mentioned the material schedule, fine. But how about rate? Are we going to prepare that one ourselves? What provision does the software has for rate? Or does it stop at that
Okay,
quantity section only?
yes, for now, it's you add your own rates. When you
Okay.
export to Excel, you can export the bill to Excel.
You mentioned that. Okay.
You
All
can
right.
add your own rates. But
Okay.
we've made provision for prices where you can check prices of building material. But in the future, we are going to add a build up rate to it.
Okay. All right. Well, thank you very much.
Thank you, ma. Okay, so we'd like to get your comments and questions. Any question? Okay, if no question, we close here and continue tomorrow by 10 a.m. Thank you all. Bye.
Thank you.
Bye. Bye-bye.
Okay.